All right, we're going to get started today. I am Garrett Chumbley, and I will be your host today. We're brought to you by CEC and Lab 46, and we're coming to you live from our homes. I want to thank our production team, which includes Angie Worrell, Sharisa Byers, Randy Montelius, and usually Chris Wood. So we thank them for allowing us to get this put together. This will be a 20 to 30-minute presentation, and due to the short time, we're going to ask you to submit your questions via Zoom or via the email information that we put up on the slide, and we will get to you back those questions back to you after the webinar. So today I'm with Troy McDermott. He has been with CEC for around 18 years, and I know a lot of you on this call know Troy, but I was wondering if Troy, you could introduce yourself a little bit.
Sure, I'd be happy to do that. So I've been with CEC since 2002. I started out in a position of network engineer and was in the field for 15 years. And then from there moved into more of a pre-sales design role. All that time was specifically in the network realm. So layer 2, layer 3 switches, routers, firewalls, wireless. Anything above that, I always handed it off to somebody else. Before that, I was with Dubuque Schools for almost 4 years. Working on the same kind of thing, networks, wireless, firewalls, a little bit of desktop support back then. And then before that, I started out on the larger network of the world. I worked for my dad for an excavating company, repairing sewer lines and water lines. So the first network that tied us all together, of course, sanitary sewer. But no, since then I've been in a pre-sales design role the last couple of years. I still get to do a little bit of work in the field. I get my hands dirty every now and then and actually fix some things, and that's been a lot of fun. It proves I haven't completely forgotten everything I learned while I was out there.
No, definitely. You are a talented person, I'm sure everybody can attest to. I was wondering if you could talk just a few minutes about some of the more interesting projects that you might have been involved with over those last 18, 19 years.
Sure. Yeah. So, I spent some time in a very large manufacturing facility. It's one of those things I took for granted in the school district that you could walk from one end of the building in less than 20 minutes. And so going to a factory that was over a mile long, that definitely adds some network challenges. When you have a switch go down, it takes a long time to get from one wiring closet to the next. After that, I kind of joke about returning to my roots. I've worked on network connected sewer manholes. So I thought that I kind of got out of that world at one point and found myself, I will say, back in it, but not knee deep in it like I had been in the past. So this time I didn't have to get my hands actually dirty working on it. But we've worked on wind turbines that were connected together, stoplights, a wide variety of kind of infrastructure type things that never used to have network connections to them that, now it's kind of all on the network.
Absolutely, and I wish I had some of those pictures of you when you were working on those projects, especially the knee-deep one. But I do have another picture that I'm gonna share with the group.
I feel like I know this is coming.
Now, Troy sent this to me years ago.
I knew this was going to happen.
Troy sent me a picture years ago, and I have it here, and I'm going to share it. Now, this picture really does a couple of things. One, it shows you what Troy used to look like. But I think for everybody else, I think the picture that we're seeing on screen right now is what everybody feels like before, the Rona or the COVID world entered. And then what I'm going to show you secondly is how everybody feels post-COVID. So I'm going to share my screen for 1 second here. And there is post-COVID for everybody else. That's a great picture. Now, I'm not sure, is that a mullet or is that an aulet? I can't tell.
Oh, no, that's all of it. I was fully committed. There was no doubt there. And of course, you can see now I used up my quota of hair back then. I hoarded it for a while, and now I'm paying the price. So quite a bit more streamlined these days than back in those days.
Excellent. And just real quick here, I'm going to throw up our contact information, or splash up. I should stop using that word. So on the right-hand side, you'll see myself, Garrett Chumbley, with my email, and then Troy McDermott below that with his email. So feel free to take a shot of that if you need to. And if you have any questions throughout the process, feel free to let us know. All right, so back to the conversation. Now that we got that out of the way, I think it's time to talk some tech. Are you good with that, Troy?
Definitely. Always good for that.
All right. So today's topic is CBRS. And some of you may have heard that term, but I know it can be complicated with all the different wireless infrastructures that are going around. So I think my first question to you, Troy, is what is CBRS and why is it unique?
Okay, sure. So CBRS, of course, we're network people. We love acronyms. It stands for Citizens Broadband Radio Service. And another term you'll hear out there is OnGo. That kind of refers to a certification group that certifies devices for it. So, when we talk about wireless Ethernet and we say Wi-Fi, CBRS, some places will say OnGo. So you'll hear that term also. So basically, it's a 3.5 gigahertz spectrum that's been freed up for use of private wireless devices. Similar to Wi-Fi, similar to cellular, we can talk about that a little bit more, but one of the things that makes it unique is kind of the history of it and where it's at today. So, in the past, this frequency range was reserved for use by the military. So used mostly by the Navy for radar on aircraft carriers. There's some other military radars that use it. Some ground-based satellite was using it, but they're basically freeing up a lot of it. Not a lot of satellite or not a lot of radar coming from aircraft carriers here in eastern Iowa. So rather than have that frequency range be reserved and not really be used in most of the country, of course, this wireless networking thing's kind of taken off. So we decided to free up some more spectrum for it. And what's making it unique is the way they're licensing it. So in the past, we had some unlicensed frequencies like what Wi-Fi uses, the 2.4, 5 gigahertz. And then we had everything else was really strictly licensed. You had to say, I'm going to use this frequency in this region, and I'm going to fork over a wheelbarrow full of money to the FCC to guarantee that I've got access to it. No one else does. With CBRS, they're using like a tiered license model, which says that basically the tier 1 incumbent users, they get priority, they can use it over everybody else. Then we're going to have some priority access licenses where a portion of that spectrum is broken into channels, and it's going to be auctioned off on like a geographic area that says you've got priority license on this. But then there's another section that's kind of general authorized access. There's really no license fee required. And if nobody else that's a higher tier is using it there, you're free to use it. So it's really easy to say, who has priority over it with these licenses. But what's going to make CBRS unique is with the cloud connectivity we have today, we've kind of got a way to actually enforce that and make it happen. So in the past, if you used a licensed area that you weren't supposed to, the FCC would have to come and hunt you down and make you turn it off. With CBRS, we're going to use a service called Spectrum Access Service, and it's basically a set of servers out in the cloud that keeps track of what devices in real time are using the spectrum, what channel and where they're located, and it basically is kind of a communication broker between all of them to make sure that, if building A is using CBRS and building B next to it turns on CBRS, both of those installations are talking to the centralized spectrum access service, the SAS as it's called, and it's going to ensure that they don't end up on the same channel. It's one of the problems we run into Wi-Fi today is there aren't enough channels to go around, and a lot of times the neighbors will end up on the same channel we're on. We end up fighting each other, and until a technical person gets called in to troubleshoot it, nobody knows that's what's happening. So that's really the kind of thing that's really making it unique. And it's a type of system that really couldn't have existed, before the cloud and before all the connectivity we have today. So really, that's kind of the unique thing about it.
That is interesting. I think one of the questions that I have when I'm listening to CBRS topics or conversation is, how is that different than what you mentioned earlier, which is the standard Wi-Fi or the enterprise Wi-Fi that we would have at our organizations?
Yeah, so it's got a lot that's in common with what we kind of think of with Wi-Fi, especially the way it deploys. I mean, you're going to have an access point, a beige box that hangs from the ceiling. That's going to be the radio. That's going to be, powered over Ethernet the same way our Wi-Fi access points are now. it's going to be pretty similar to that. There's a couple differences, and we won't get too deep technically here, but we definitely can if anyone's interested. If you look specifically at it, it's going to be a narrower channel width than what Wi-Fi uses. It's going to be 10 and 20 megahertz as opposed to Wi-Fi, which is a minimum of 20, ranges up to 160, really wide. But it's going to have a lot higher transmit power, so that's a big benefit compared to Wi-Fi. And we're going to have a lot lower noise compared to Wi-Fi. Because Wi-Fi is unlicensed, we run into a lot of cordless phones, baby monitors, AV devices. I've seen scoreboards, signs at gas stations. A lot of those things are in the same spectrum as Wi-Fi, and so we get a lot of interference from that. CBRS, both because it's fairly new and there hasn't been a lot of devices out there, and then also because we've got this spectrum access service, is going to really cut down on what that background noise is. So when you combine that lower noise with a lot higher transmit power, a good analogy is you and I having this conversation in a bar versus me standing in a library with a megaphone. One of those two situations, you're going to have to be pretty close to me. That's kind of like what we've got with Wi-Fi. If I've got a megaphone in a library, we can have a really big library and you can be at the far end of it. And you're still going to hear me with a good, clear signal. So that's probably kind of the biggest difference with Wi-Fi, is that we're going to have, more coverage, which has kind of been a problem for Wi-Fi in some spots, especially when you get into outdoor areas or challenging RF environments. If you talk about the channel width, though, we're going to have a little bit narrower channels. That's gonna be realized as lower throughput. So the amount of devices per radio and how much bandwidth they can really push through that radio, that's still going to be higher than Wi-Fi. So those are, that's where Wi-Fi is going to work better. One other thing to mention is under the covers, CBRS is basically using LTE signaling, what we kind of know as cellular. Which is great. That's a proven technology. It's had a lot of thought go into it, a lot of testing, but it also means the devices are going to have SIM cards. They're going to have to be compatible with band 48, the LTE band that CBRS is using. And so it's not something where your guests are going to walk in off the street into your parking lot and be able to jump on your CBRS network like a guest. The way things are kind of set up today, if you own that network privately, it's going to be devices that have your, SIM cards in it set up. They're going to have access to the network. So, it's going to be great where Wi-Fi would have required a whole lot of access points to get the needed coverage and reliability. But, there aren't an abundance of devices getting onto it. It's going to be perfect. So it's definitely not going to replace anybody's Wi-Fi. It's going to be a complementary technology.
I see. So, I think in today's world of physical security being a big topic, as well as network security, does CBRS help or hurt that process of securing a network?
It's going to be definitely helpful. So, and there's two really levels to it. We can talk about the security of CBRS. Again, it's using LTE, which uses encryption. It's definitely been tried and true, tested. Nothing's invulnerable, but it's always good to see the standards bodies reusing something that's been tested and worked rather than coming up with something brand new, which is kind of what happened with Wi-Fi. The encryption Wi-Fi was using when it was new was kind of designed just for Wi-Fi, and it had some fatal flaws in it. So hopefully we can avoid that on the security side of things. But then if you look at the larger sense of I need to secure my resources, my people, my buildings, one way to be able to have wider wireless coverage will do that. I can put my cameras farther away. I can get them farther away from the building in the parking lot. I can have my staff get farther away from the building or farther away from a radio and still have coverage for, a push to talk radio or a tablet showing video feeds, a lot of those things. So I think security is one of the specific spots where CBRS will definitely be useful.
I see. So when you're thinking about, based on what you were saying about the Wi-Fi, the LTE, the cellular, and the applications, and I know there's a lot of situations where, a factory or even a parking lot needs coverage. Could you talk a little bit about some of the benefits that CBRS would specifically improve as it relates to cost as well as application for those two areas?
Yeah, definitely. So manufacturing is a prime example there, because I know that one fairly well. And manufacturing and warehouses have always been challenging from an RF point of view. It's very seldom that walls move in an office environment, but in a factory, we might go from a 40-foot high rack filled with rolls of steel to not being there anymore. It's the equivalent of a wall moving. We do wireless site surveys to try and predict where we need to put radios. We kind of bank on the building not changing its configuration, and that's exactly what happens in a warehouse situation. Combine that with the fact that primary application in warehouses a lot of times is a barcode scanner, so I don't need a lot of throughput. I don't have thousands of client devices, so warehouse is a perfect spot for it. Manufacturing is good. In general, outdoor parking lot coverage. If I can cover a giant parking lot with one radio rather than a series of directional Wi-Fi radios, and then I don't have to, worry about do I need to make sure it's configured so my guest network is not going into the parking lot, so it's preserved for security devices. CBRS will help solve that as well, and then I can get back to letting my Wi-Fi network does what it does best. I can have high density throughput, guest access, things like that. And then my IoT devices, my security devices, I've got those on a separate solution. So I don't have to worry about a problem with one affecting the other.
So how do I pull those together? All those different types of wireless networks, LTE, cellular, enterprise Wi-Fi, CBRS. And how do we pull all those together to really come up with a solution that makes sense?
Yeah, I mean, we do that all the time, and it's different for every customer. It's important to really look at not, how do I make my CBRS network do what it's supposed to do? We'd like to take a step back and say, what am I trying to solve? Do I need a device that has access? It used to be pretty easy. If the device was staying inside my network, inside my building, it was Wi-Fi. If it was out there leaving my building, well, then I get a Verizon card that goes in it. With CBRS, I can kind of split that difference. And, one thing we'll be able to talk about too is since it's LTE, it's going to allow some roaming capabilities, much like, if I've got a Sprint phone, I can roam to Verizon's network and vice versa. So again, it's something where we take a step back and look at what is the problem we're trying to solve, and then we look at what tools we have in the toolbox and try and make sure we're applying them in a way that works for what we have today and also leaves us some options in the future.
Yeah, and something that you said earlier, and you might have actually answered this question, but I'm going to ask it again because now I'm curious. So when we have the Internet of Things all coming everywhere, even my cameras, do you see a day where our cameras or some of our IoT devices will have CBRS ready chips, if that's the right word or words to say in there?
Yeah, so that's a good point to talk about now is client devices. So I mentioned that everything has to be CBRS compatible, and you can look, at an iPhone 11, you can look at the specifications and it'll say it supports band 48. If you see it supports band 48, that device does CBRS. It's fairly recent. It's kind of an infant in the world of wireless technology. We haven't hit that critical spot where all the LTE devices support it. But the last round of iPhones, the last round of iPads, the latest Samsung Galaxy phones, I think the Google Pixel 3, Google Pixel 4, basically we're seeing a lot of the high-end devices from last year were coming from the factory with band 48 capability. So that's a great vote of confidence for this. That says that these manufacturers believe going forward that that's going to be a useful network for these devices. So as we get more and more of those out there, we're going to get more capabilities on there. I don't think it's going to be very far at all where we're going to see security cameras where you can get it with band 48 capability. And even today, there's a variety of companies are making an Ethernet to CBRS bridge, low cost device. Basically, you can CBRSify any of your existing cameras today or your IoT devices. I think Symbol's one of the companies that has a CBRS. I know there's a company out there has some CBRS compatible barcode scanners already for warehouses. There are a few devices today, definitely nothing like Wi-Fi. but we're seeing that number grow continuously. So as more and more devices come out, yeah, I think you'll definitely see like this is going on my CBRS network, so I need a, you know, this model camera that supports that.
Oh, very good. So I have, one more question on top of what you were talking about, because you were talking about some future areas. What are some other cool things that the future could bring with utilizing CBRS?
Yeah, so I talked a little bit about the, you know, it's LTE under the covers. It's using the same signaling. It's going to, and it does, it's just a matter of once the devices support it. So it's going to be pretty easy to configure my private CBRS network to say, okay, I'm going to allow my devices with my SIM cards on there. CBRS is designed in mind and has the capability for me to say, oh, I'm also going to allow anyone with a T-Mobile SIM card onto my private LTE network. And so then what I'm doing is I'm basically a network operator providing roaming capability to, you know, another network operator. So people with T-Mobile devices can come into my buildings, get on my CBRS network, and they've got connectivity through the CBRS system out to T-Mobile's core network. They've basically got cell coverage where maybe they didn't in the past. You know, I mean, we've got a lot of 100-year-old, 150-year-old stone buildings that don't have great cell phone coverage in it. CBRS is going to be able to augment that cell phone coverage. So really just a matter of time before I know there's enough devices out there. And, you know, say more than 50% of cell phones that are out there are band 48 capable, that's going to be an invaluable function of CBRS. That's really going to, you know, we've kind of got solutions for that today with distributed antenna systems or DAS, but the thing to remember with DAS is I'm really just amplifying the wireless signal that hits the outside of my building and rebroadcasting it internally. I'm not really providing any extra throughput than what that one tower can support. With CBRS, I'm actually encrypting that traffic and sending it out my internet connections to T-Mobile, Verizon, to whoever the network operator is that I'm providing roaming for. And they are, so then it's just a function of how much bandwidth I have allocated for them to use. So basically I provide a lot of capacity and roaming capabilities.
Well, great stuff, Troy. I wondered, so let's say I have a specific application, or if I want to learn more about the technology, which you're obviously an expert at, what would be my next step as a customer?
Yeah, I'd say call CEC. Get in touch with me directly, or Garrett, or any of our account managers. They'll all know how to get a hold of me. They might roll their eyes a little bit because they know they'll have a lot to hear about. I tend to get excited about this stuff. I love to talk about it. So yeah, I would say get in touch with us. You know, I don't know everything there is to know about it, but I've got a lot of great resources. So yeah, if I don't know the answer, I can definitely get in touch with somebody. We've got good partners on the CBRS side of things that we can get in touch with as well. And yeah, if you've got a problem that Wi-Fi isn't solving it, or cellular isn't solving it, get in touch with us, and maybe CBRS can solve it. Maybe it can't. But yeah, I'd love to try and help out, take a look at it, see if we can't come up with a solution.
Excellent. And I think that brings me to my next comment, which would be, Troy is obviously an expert on all things network, both in your building and in the ground. So I think another something I want to talk about, which is not to inflate Troy's ego, but he's a very humble person. But the guy seriously knows everything about everything. So I have a challenge here, and it's the Stump Troy Challenge. So if any one of you customers, not CEC employees that are listening, can actually stump Troy on any topic, whether it's about a Jeep or a bicycle tire or whatever, how toilet paper is made to be relevant, I want you to hit him up when you're seeing him in the hallways. And if you can stump him, I'll buy you lunch or a coffee, whatever works. Is that all right with you, Troy?
Yeah, I think that's great because personally, all I can think about is all the stuff I don't know. So I would love nothing more than someone to ask me something I don't know anything about, because then I get to go learn something new. So I can, yeah, if I don't know the answer to your question, I'll be more than happy to find it, whether it's about, yeah, bikes, Jeeps, networks. You probably don't want to ask me about toilet paper because the spot in the life cycle that I've got the most experience with that is not one you're probably too curious about. But again, if you have questions, I know people that know a lot about sewer networks. I can go ask them too. So, but yeah, definitely hit me up with any questions related to anything.
All right. Well, to recap, we're going to wrap this up. We're a little over our 20 minutes, but so the key themes of today is Troy can fix your network, both above ground and below ground. Troy rocked an all-it or a mullet all-it back in the day. The hashtag Stump Troy project that we have going on. And then finally, CBRS is a great addition to really help solve some really challenging problems. So again, thanks to our production team that I mentioned earlier, and you, the audience, for participating. And that definitely concludes our discussion today. So from our house to yours, and from everybody at CEC, we thank you.